Okay, so today we are talking about our final form of solving that we are going to learn for quadratics. Put the laptops away for now, please. So, technically, with factoring, solving by square roots, completing the square, and graphing, we are in a position where you should actually be able to solve any quadratic equation I give you. You have the tools necessary, or at least I've given you the tools necessary. Some of you need a little bit of practice, and that's perfectly okay. But there is one other tool available. It's especially great for questions like the one that I just did on the active board, where all of a sudden completing the square gives you fractions to work with, which are not our favorite thing in the world. The last form of solving, you've seen it before, is quadratic formula. Now, the quadratic formula is built using completing the square in a situation where they start off giving you an equation in the form ax squared plus bx plus c equals 0. In other words, they give you a quadratic trinomial, but they leave a, b, and c in there as they go through the process of completing the square. Now, I could show you all of that wonderfulness. It's beautiful. But in my experience, most people kind of are like, she just did a bunch of scary math. And then they check out because they think quadratic formula is the worst thing in the world. When actually, in many cases, a lot of people find it one of the easiest ways to solve. So you do have to have a quadratic equation in the form ax squared plus bx plus c equals 0. If you have parentheses squared, you cannot use the quadratic formula on it without at least getting it into this form. If you are missing a term, either b or c, you got zeros in those places. So this can still work for situations where you have equations like 3x squared plus 7 equals 0. You would just think of the number of regular x's you have as 0 x's, and b would be 0. The quadratic formula is as followed. X equals a big old fraction. And the numerator of that fraction is negative b plus or minus the square root of b squared minus 4ac, all getting divided by 2a. And the year before. You've seen quadratic formula before. Quadratic formula is used to solve quadratic equations. It will not factor, it will not do other things, but it will solve. Answers should be exact and simplified. That is where some things are going to be a little bit different than what you did in previous classes. Previously, maybe a little bit in geometry they wanted exact, but in Algebra 1, generally, you were allowed to give decimal answers. I don't want decimal answers. So 2x squared plus 4 is equal to a negative 7x. If I want to solve using the quadratic formula, first thing I want is I want it equal to 0. Add the 7x to both sides. Make sure you are not combining unlike terms, but you are combining like terms. In this case, there aren't any like terms, but it is something to look out for. 2x squared plus 7x plus 4. Now, when you are solving, generally speaking, quadratic formula, completing the square, those are generally the last options I try to do because they are the most tedious. But that's a me thing. If you are really, really struggling with factoring, this can be a way to solve. But I would still recommend that you get some factoring solving down, and then solving by square roots will solve equations that show up in a different form. So once you get it equal to 0, identify your A, identify your B, identify your C. Be careful of positives and negatives. What's A? 2. What's B?
7.
What's C?
4.
Perfect. And then you plug into the formula. X equals negative B plus minus square root of B squared minus 4 times A times C all over 2A. Now you'll notice that when I plug it in, I always put everything in parentheses. I get asked every time, do I always have to put it in parentheses? And the answer is yes and no. Were the parentheses necessary for me to put a negative in front of a 7?
No.
No. Were they necessary for me to put the 2 next to the 2?
Maybe. Depends on whether or not you put a multiplication sign between.
Depends on if you put a multiplication sign in between. If you put a multiplication sign in between, that's perfectly fine. Same thing with the 4 and the 2 and the 4. If you put multiplication symbols in between, that's fine. 7 squared, do I need parentheses?
Yes, if it's negative.
Yes, if it is negative. If it is negative, you absolutely need parentheses here. Rule of thumb, it never hurts to put the parentheses in all the places. At very minimum, I would always put parentheses here. Now, at this point, people tend to go to their calculator, type that entire thing in, and then the calculator does not give them the right answer. You have to be careful with how you type this into your calculator. The calculator will not take this entire thing nicely. So we have to simplify it in pieces. The first pieces I simplify is just paying attention to the numbers. The negative in front of the 7 is just negative 7. The 2 times the 2 just turns into 4. And then I take the stuff inside the square root. Note, I did not say the square root itself. Leave the square root out of it. The stuff inside the square root, I type that into my calculator all in one go. Did I take the square root? If I did not take the square root, does the square root symbol go away?
No.
So simplify in pieces first. Especially since, if I want exact answers, am I going to be taking the square root of 17? No, it's not a perfect square. Can I simplify the square root of 17?
17 is a prime number?
17 is a prime number, so it does not divide by any perfect squares because it is not a perfect square. Technically it divides by 1, but 1 is not a helpful perfect square. I cannot simplify the square root of 17. If I cannot simplify the square root of 17, what I'm able to simplify here is very, very limited. When it comes to simplifying with the square root, you simplify the square root itself. Done. We can't. And then you look for the 3 whole numbers in the problem. How many whole numbers do you see here?
2.
2. Where's the third one hiding?
In front of the positive and negative.
Not in front of the positive and negative. In front of the square root. After the positive and negative.
1.
There's an invisible 1 right there. The only way you will simplify any further at this point is if all 3 whole numbers divide by something. Does -7, 1, and 4 all divide by the same number?
No.
No, then that's your answer.
Okay.
Don't mind me, I'm just realizing I'm not a huge fan of the next problem I have. But I'm gonna run with it. It's fine. Where do you think I should start? Add the 2x. I want it equal to 0. X squared minus 6x plus 4 equals 0. Combine your like terms as you do this. Okay, it's equal to 0. Next thing I should do, identify what things? A, B, and C. What's A? 1. What's B? -6. What's C? 4. Identify the things and then do what with them? Log them into our quadratic formula. Quadratic formula says x equals -b plus minus square root b squared minus 4 times a times c. Just replacing the letters with their numbers. All over 2 times a. How does that look? I heard a no. Did I screw something up? You mean this?
Yeah.
I do that on the next step, but you're right.
What are the parentheses on the second 6?
Does this absolutely need parentheses?
Yes.
Yes, because -6 squared and -6 in parentheses with the squared outside are not the same thing. If I type this into my calculator, just this part, I get that. Versus this, I get that. They give me the same thing?
No.
No, it's going to cause issues. Make sure this is in parentheses, especially when it's negative, and make sure the squared is outside the parentheses. You put the squared inside the parentheses, you're causing the same problem. If you want to jump directly to negative is a positive, you can, but the reason I do not is because when people do that, I tend to find they make more mistakes. Plus, minus. What else can I simplify?
The entirety of everything under the square root.
The entirety of everything under the square root, including the square root?
No.
No. Leave the square root alone.
Not square root, so.
I got 20. How about you? Yes, no, maybe?
Yes.
All over.
2.
I can also simplify that. Can I simplify this further?
Yes.
Yes, why?
20 is something.
20 divides by a perfect square. I tend to do this part off to the side. Square root of 20 is square root of what times square root of what? Square root of 4 times square root of 5. Which of those was the perfect square?
4.
Becomes
2.
2 square roots of 5. Okay, so now I've got 6 plus or minus 2 square roots of 5 all over 2. I simplify further if I can.
Divide the 2 into the 6.
Not just the 2 and the 6.
You can also divide the 2 and the 2. It's multiply.
Not just the 2 and the 2. What numbers will all simplify?
6, 2, 2.
The 6, the 2, and the other 2, which I think may have been what you meant in the first place, or did I say afterwards?
Oh yeah.
These 3 can simplify. Question for you. Can I just add the 6 and the 2?
No.
Can I subtract them?
No.
Why not?
Because it doesn't
They're not like terms. The 2 has the square root of 5 on it. I can simplify though, because all 3 of these divide by
2.
2. 6 divided by 2 is 3. 2 divided by 2 is 1. The 5 doesn't get touched. 2 divided by 2 is 1. Do I really need either of those ones?
No.
If you leave it, I'm not going to be upset. But it's 3 plus or minus the square root of 5. I want to talk about one more example. Now, the one more example is going to leave one thing off that I wish I would talk about today, but for the sake of time, we're just better off having a quick conversation about it. So, before I move on to the next problem, the quick conversation I want to have has to deal with that square root of 20. What if that 20 was negative?
It would be an I.
There would be an I involved. So, if you have that, make sure you can still get the imaginary answers using quadratic formula. Remember, even if this didn't have a square root of 5, if it had the I on it, they're still not like terms. Okay, our final example we're talking about today. X squared minus 5x plus 6 equals 0. First things first, get it equal to 0.
That's already done.
Done. Identify your A, your B, and your C. A is,
1.
B is, C is.
6.
Plug into your quadratic formula. This part I'm doing fairly quickly because of the fact that, for the most part, y'all know what numbers to plug into what letters, and you're fine with that. Simplify what you can. Negative, negative, positive 5. 2 times 1, 2. Square root. What do I get when I do negative 5 squared minus 4 times 1 times 6?
1.
Anyone else get 1? See a couple people shaking their head. Beautiful. Can I simplify this?
Oh, no.
1 is is a perfect square.
Oh, yeah.
Square root of 1 happens to be
1.
1. Are all numbers their own perfect square?
No,
No,
that one's just.
it's
very
just 1.
special.
These are like terms. If they are like terms, what do you think I need to do? Split it into 2 equations because it's technically 2 in 1. 5 plus 1 all over 2. 5 minus 1 all over 2. Make sure you do the numerator first, and then you divide. In this case, I got 2 nice whole numbers. Reason being is there would have been a faster way to solve this from the very beginning. Isn't this a nice, straightforward shortcut to AC method problem? 2 things that multiply to 6 and add to negative 5. Negative 2, negative 3.
Yeah.
Would have been x minus 2 and x minus 3. Set them equal to 0 and we get x equals 2 and x equals 3. Less work?
Yeah.
Yes, but do you have to recognize it?
No.
If you're going to do it, you'd have to recognize it. But yeah, if you don't recognize it, you can do it this way. But if these are like terms, you do need to combine them. And then simplify your fraction. Do not go to your calculator and try to type in 5 plus 1 divided by 2. Calculator don't get it. He's confused. Okay, that's enough of me talking. Yes.
Do you want us to do that method over the AC method then?
Here's the thing. When it comes to solving, I want you to have multiple ways to solve. If you look at something and you're like, I recognize that especially shortcut to the AC method, I would just do this. I wouldn't do this by quadratic formula. But if you missed it, you could still do quadratic formula. Okay. Today's homework assignment's a little bit odd in the sense of there are some things on the homework assignment that I haven't talked about yet. Because we are going to be finishing up this section tomorrow. And I'm going to talk a little bit about something I haven't talked about. It's a real small thing that we add to the quadratic formula stuff. And I didn't want to split it into 2 different homework assignments. So, today, you can get up to 14 with the stuff that we've talked about. 15 through 20 is something slightly different that we're talking about tomorrow.
So we have homework assignment.
Tomorrow is not a new homework assignment. Tomorrow there's a little bit of notes and then work time and possibly a mini quiz.